Hey guys, welcome back. How you doing? So I want to apologize because I know we've been doing a lot of calculus stuff recently. It's a little bit boring. It's kind of irritating. I hope I explained it in a way that's kind of exciting and not too difficult to understand. There's not going to be too much of those types of videos in this, but they need to be included so that everybody can follow along. So thank you for those that did. If not everything made sense, that's totally okay. We're going to use the calculus now for the reason that pretty much the entire machine learning course, it just a little bit more complicated later. The reason that we learn the calculus at all, which is just these derivative things, is that if you set them to zero, so imagine that this is our function where it's our mean squared error. So it doesn't necessarily look like this, but suppose that our mean squared error looked like this. If we just looked at beta naught on the x-axis, so here you can pivot, you can imagine changing different values of beta naught, and this, the y-axis, is the associated error with each of these. So if we had one value of beta naught, which was this, then maybe the mean squared error was this, which is bigger than it is with, say, this value of beta naught. If we picked this value of beta naught, which happens to be 0, it's probably not the right choice for every single model or every single piece of data. But the point is that we need to try and find the beta naught that gets this thing to this minimum. And it turns out that for this mean squared error function, it's going to be this kind of bowl shape like this, where it's not necessarily around 0 like this. It's not necessarily set beta naught equal to 0, you get the minimum value, but it might look like something like this, where over here, if I extended the axis, maybe we found that if you set beta naught equal to whatever this value is, say -5, then you're getting the minimum value there. Okay, and I'm going to erase that because I know it's getting kind of a messy drawing here. But basically the point is that wherever it is, it's always that it's this curve like this, like this. And that means that the derivative is equal to 0. So this flat thing, if you have this tangent line, remember that's the derivative. So wherever that derivative is 0, that should have been flat, it didn't really look flat. Wherever the derivative is 0, aka that tangent line is flat, that means that it's at this minimum. And it turns out that it doesn't look like this, okay? It could have also, the function also could have looked like that, which would have meant that this was a maximum, which we don't want, we want the minimum error. It turns out that it happens to be a minimum. So all we have to do is set the derivatives equal to 0. So that means the derivative of the error function with respect to beta naught, so that's actually a partial derivative. We set the partial derivative of the mean squared error with respect to beta naught equal to 0, and we do that with beta 1 as well. We solve this system of equations that's going to come up. We get an exact answer, which is going to be very rare for the machine learning course. Most of the time, we're not going to get an exact answer. But in this case, we're going to solve for an explicit answer, which means we get a formula for beta naught and beta 1 to get the best line, the line that minimizes the mean squared error function. Okay, so in the next video, we're actually going to do that. I don't want to fit that all into this same video. In the next video, we're going to get the derivatives of this function, of this thing, get the partial derivatives with respect to beta naught and beta 1, and solve that system to give you a formula for each of these. And I will see you tomorrow.